Hi there, I'm Hao, and this is just another video of me solving random code problem. So let's get started. We have average of levels in a binary tree. So we are given the root of a binary tree. So we need to return the average at each level. So for example, in the first level, we have 3, right? So 3 is only have one element, right? So the average is 3. So if we have two elements here, which is 29 divided by 2, right? It give us 14.5, right? In the last level, we don't have anything on the left subtree here, but we have two elements on the right, so that is 22 divided by 2, and it'll be 11. Right? That's what we have. So that's pretty straightforward. We can just use a breadth first search to solve this problem though. Just keep track of the sum of the elements, right? And then divided by the total number of elements. So in JavaScript, there's no built-in queue. So I just want to use a queue here, a custom queue here. But that we're not gonna because if we use an array as a queue, shifting, like first in, first out, right? We shifting from the front when I give us on, right? So using a custom queue allow me to have pushing and popping in constant time. Okay. So first thing first, we need a result array. Or you know what? Let's call this one average. Right. Let's be descriptive with our naming convention here. Average. Right. Okay. So we will return the average at the end. Right? So what else do we need? We need a queue, right? Because we are using breadth first search, first in, first out. So equal to new my queue, and we have to enqueue the root, right? And we have to keep track of the current level, right? Which is at 0 here. Okay, so now we already have the first element. We need to iterate to the queue, right? The y to the line, right? We need to keep iterating, right? And then we need to look at the current level. So which is let's call this current level, right? Equals to q dot click. So this is the element that is about to be popped, right? And we need to iterate through every element on this level, which is on the next level, right? Current dot length equal to q dot length. So for let I equal to 0, I less than current dot length, I plus plus. Okay, and then the node and then level here will be equal to q dot pop, right? And then we need to add we need to check the sum, so add equal to the node dot round. So we need our sum equal to 0 here. And if we have a left, right, we push it into the queue. Queue dot push, node dot left, right? If we have node dot right, we're gonna add the node dot right, right? But we have to also keep track of the level, right? The next level will be level plus one. Okay. Um. So the for loop here, right? We're gonna iterate over the current length, right? Which is the number, the total number of element on the next level, right? Level plus one. Okay. And yeah, we just keep track of the summary. So after that, we need to put it into the average, right? Equal to the average at current level, right? Current level is to be equal to sum divided by the current length, right? Yeah, so that's pretty much it. Um, You just iterate over every single node on the current level, sum it all together, and then divide it by the line, right? To get the average. So let's walk through it. Some example here. So the first time, right, we're gonna have 3, right, as the root, right? So our current length gonna be 1. We only have 1 element, right? And we just pop it off, right? We iterate over one time, right, and pop it off the cube, 3 off, right? And we add 3 to the sum, right? 3 to the sum, right? Then, right? So and yeah, and we if there's left and right, we just add it to the cube, right? And then it is level 0, right? And then we add it to our average, right? So the current level gonna be level 0, right? Because we look at the current level before we pop it off, right? So it's giving the level of the 3, which is 0 here. So we add it into our average, right? Which is at level 0, like 0 here, right? Index 0. So it's 3 divided by the length, right? So 1, so 2 divided by 1 is 3, right? And we keep going, right? So now our level, our is gonna be 2. So we have 2 elements, right? In the next level here, right? And then our level gonna be 1, right? Because now it's at level 1 here. Right? This is what we're gonna add. 9, 1, and then 21. Right? 1 is the level here. Okay. So we keep track of the sum, right? We iterate over current length. So we iterate 2 times, right? To pop up the 2 elements. It's gonna be 9, right? Plus 20, right? So let's do one by one. So we do 9, we add it into the sum, right? Pop it up, of course. And then we need to add the if the 9 have any left and right, right? And this doesn't have anything, so we can ignore, right? So our sum is 9. So we pop up the 20 now, right? Add it into our sum, so 29, right? The 20 have left and right, right? So at 15, right? At level 2, and then 7 at level 2, right? So now we are done. We divide the 29 by 2, right? Which is 14.5, add it here, right? Now we pop this up. Our length is also 2, right? Our level is now 2 because the peak, right? The peak here, we level 2. Yeah, we pop it off. There's no left and right elements, right? So I'm gonna be 15, right? So we pop this one off, plus 7, right? There's no left and right children, so we are done. So 22 divided by 2 is 11. And yeah, that is our algorithm for breakfast here. So let's try that, and it worked. Thank you for watching.